All right, this is going to be the second part of lesson 6-2. First thing we're going to do is we're going to view a couple things from the previous days. First one is oxidation numbers, and then we'll look at reviewing of polar covalent molecule, and then we'll look at today's new information, which is on nonpolar covalent molecules. So first of all, oxidation numbers. Remember, this is how many electrons it wants to gain, lose, or share to become chemically stable. So we first look at aluminum, and aluminum is group 13, so it has 3 valence electrons, and it has 2 choices. It could lose those 3 valence electrons and empty that shell, and then the shell underneath it is full, so it would be chemically stable, or it could gain 5, and it takes the shorter route, so it's going to lose 3 electrons. If it loses electrons, it becomes positive, and it's losing 3 electrons, so it's going to become charged 3+. Calcium is in group number 2, so it's 2 valence electrons, and it wants to give away those 2 valence electrons and therefore become positive, and since it's giving away 2, it becomes 2+. Chlorine is in group 17, has 7 valence electrons. It wants to gain 1 electron to get to 8. If it gains 1 electron, it's going to have a charge of 1+. Sulfur is in group 16, would want to gain 2 electrons and become charged 2-. Nitrogen is in group 15, so it has 5 valence electrons. It wants to gain 3 to get to 8, and if it's gaining negative electrons, it becomes 3- charge. Lithium is in group 1, has 1 valence electron that it wants to get rid of, so it becomes +1. Silicon is in group 14, and remember we've talked about they can gain or lose, but generally if they're in group 14, they will want to lose those and will become positively charged. So there's a review on valence electrons being lost or gained for an atom to become stable, an element to become stable, and the oxidation numbers that result. Next, we're going to take a look at a little review from yesterday, and that's a dot diagram to show how hydrogen, in this case phosphorus, will combine and form a molecule. So we start out with hydrogen, and we draw a dot diagram, and we have 1 dot for hydrogen, and for phosphorus, it is in group 15, so it has 5 valence electrons. And one way you can take a look at what it wants to do is just drawing boxes here of empty spots that it would like to get an electron. So you can see here that phosphorus wants to get 3 electrons. Well, hydrogen we know has to share. It can't give away its 1 electron because it only has 1 shell. So hydrogen wants to share, and the hydrogen could fit right in here to share, but phosphorus needs 2 more hydrogen in order to become stable. So we draw those 2 extra hydrogens, and we put their valence electrons here. I'll make 1 in green, and I'll have 1 in black. And then these 3 hydrogens are going to share with the phosphorus. So we're going to put the phosphorus, and we're going to put the 3 hydrogens surrounding the phosphorus. And the 1 hydrogen says, I'll share 1. The other one says, I'll share 1. And this one says, I'll share 1. Phosphorus says, okay, that's fine. I'll share 1 with you, 1 with you, 1 with you. And then the phosphorus had 5. 3 are being shared right there. So there's the 4th one, and there's the 5th one. So you can see now that phosphorus, remember, whatever they're being shared, whatever's in between, they get to use. So phosphorus gets to have these 2 that it's sharing, these 2, and it also has those 2 of its own. So phosphorus has 8 around it. So it's stable with 8 around it. And hydrogen, remember, is stable with 2. So this hydrogen has 2, it's stable. This one has 2, it's stable. This one has 2, it's stable. So the hydrogens are stable, the phosphorus is stable, and that compound, name-wise, is going to be hydrogen phosphide. And, oops, got an N there. And then if we look at if this is polar or non-polar, we have more electrons around the phosphorus. The phosphorus has 8 electrons around it, so it is more negative than the hydrogen, which only has 2. So we show that with the negative sign being up there, and the positive sign is going to be 180 degrees opposite, in this case on the bottom. Now, if instead I would have drawn this one like this, then what we would have is our negative would be over on this side, and our positive would be on this side. So it depends how we draw that, what it looks like. But this would be then, since we have a negative side and a positive side, then this is a polar covalent molecule. And remember, a molecule is a neutral atom or a neutral particle from electron sharing, and covalent tells you it's sharing. So that was a polar covalent molecule. And let's go down, and our next example is new, and it's going to show you two examples of a polar or a non-polar covalent molecule. And these are, first one we're going to look at is a diatomic molecule. All diatomic molecules are going to be non-polar. So let's look at hydrogen, combining with another hydrogen. Hydrogen has 1 dot. This one also has 1 dot. They're going to share. And this hydrogen is going to share 1. If that hydrogen shares 1, that's 1 dot. And if we take a look at that then, if it was polar, that would mean you'd have one element that's more negative than the other. In this case, this hydrogen has 2 electrons around it, and this hydrogen also has 2 electrons around it. It only has 1 shell, so that's stable with those 2 electrons, but it's equal sharing of electrons. So since it's equal sharing of electrons, this is a nonpolar covalent molecule. And we do not put a negative or a positive sign anywhere. We also don't put charges, like when it's an ionic compound. We're not going to put that it's a 1+, okay? Because this is a covalent molecule, so we only show a negative and a positive sign if it is polar. In this case, it's nonpolar. Let's look at another nonpolar one. In this case, we're going to take silicon, and we're going to combine it with iodine. So originally, we find silicon has 4, and iodine, oh wait, not silicon, sulfur. I'm sorry, sulfur and iodine. So sulfur has 6, and iodine has 7 electrons. 1, 2, 3, 4, 5, 6, and 7. So if you draw in what they want, sulfur has 2 spots that are open, iodine has 1 spot that's open. So iodine could share with the 1 sulfur. The problem is sulfur needs another to share with it. So we would need another iodine. So we need to draw that other iodine here. And that iodine also has 7, 1, 2, 3, 4, 5, 6, and 7. And it also has 1 spot. So that therefore, these 2 are going to combine, or these 3 are going to combine. Sulfur is going to be here, and then it's going to have iodine connected to it. And you can just draw it bent. Don't draw it in a line, but draw it bent. So we're going to draw 1 iodine there. We're going to draw the other iodine there. And this iodine says, I'll share 1 with sulfur. And sulfur says, I'll share 1 with you. And the other iodine says, I will share 1 with you. Sulfur, if you'll share 1 with me. Sulfur does that, and then sulfur has its other 4, giving it a total of 6 that it started with over here. It had the 6 originally, and you can see the 6 red dots. The iodine now shared 1 and has its others, so it has a total of 8. And the other iodine shared 1 and has the other ones, so it had 7 originally, and then it's getting the 8th one with the sharing from the sulfur. So now we take a look and determine if it's polar or non-polar. And do we have opposite sides. Do we have one that's more, one area that's more negative than the other area? And we take a look at this, and we have 8 electrons around both iodine, 8 electrons around the sulfur. So this is not opposite sides. We don't have any part that's more negative than the other. This, again, is a nonpolar covalent molecule. That being said, we don't have charges. We're not going to put a 2+ here because that sulfur did not gain 2 electrons. It's sharing electrons. So we don't have that. We also do not have a negative side and a positive side. We don't have that because it is being shared equally. So this is our final product, and that is how we draw it, and we will label that as a nonpolar covalent molecule. Tomorrow we'll review some different polar and nonpolar molecules and some diatomic molecules, and we will go over the assignment, so make sure the yellow in the bookwork on page 187 is done for tomorrow. Definitely need to be reviewing your notes, so you remember things like what the diatomic molecules are, what is meant by, what are cations, what are anions, and so on. So continue to use your notes to review, as this is a pretty difficult chapter, and we'll see you tomorrow.